In this problem, it says that a popular theory is that presidential candidates have an advantage if they are taller than their main opponents. We have a list of heights of randomly selected presidents along with the heights of their main opponents. So in part A, it asks us to use that sample data, and I'm going to put the heights of the presidents into L1 and the heights of the main opponent into L2. So we've got our data in the calculator. We're going to use a 0.05 significance level to test the claim that for the population of heights for presidents and their main opponents, the differences have a mean greater than 0. So for the null hypothesis, I'm going to write that over to the side. The mean of the differences will equal 0. And the alternative hypothesis, the mean of the differences, and we have to see, is this a greater than or a less than situation? We want the mean to be greater than 0. And then I look to see what the individual differences are defined as. So we're taking the president's height minus their main opponent's height. So that's L1 minus L2. So we're going to say this is greater than 0 because we're assuming the president height would have to be the larger of the two. And so L3, I'm going to type in L1 minus L2. So you need to be in the heading of L3. So you have L1, L2, and L3. And you have your data, 186, 185, and so on, in L1. Then you have 175 and 177, and so on, in L2. And L3, we need to be up in the heading and type in L1 minus L2. And this will give me the list of differences. So the first difference is going to be 11, the second difference is going to be 8, and so on throughout that. So we've got our data in, we've got our null hypothesis and our alternative hypothesis. So let's go to the next part of the question where it asks for the test statistic and the p-value. So now we want to find our test statistic and p-value. So to do that, I'm going to do a t-test. And we're going to use data because in these matched pair problems, we always have to choose data. The value of mu 0 is 0 because that's the value from the null hypothesis. And because we chose data, it's going to ask us for the list, and that is L3. So it's important that you have the correct list in there. And then underneath that, it'll say frequency, and we just want that to be 1. You should just be able to skip over that. Let's see. And then we need the alternative hypothesis. So that's going to be that mu is greater than mu 0, right? Because we just want the inequality to point in the same direction as it does in the alternative hypothesis. So we've got that. We can use calculate or draw, and we get our test statistic is 0.37, rounded to 2 decimal places, and the p-value is 0.364, rounded to 3 decimal places. So now I can compare my p-value with the significance level alpha, which is 0.05, and the p-value is larger than alpha. So that's going to lead us to the conclusion that we should fail to reject the null hypothesis. So let's take a look at the next part of the question where it asks us to use that information. So here it says, since the p-value is greater than, so we're going to choose greater than the significance level, that's where we fail to reject or do not reject the null hypothesis. So the claim was the alternative hypothesis. If we look back, the null was that mu sub d is equal to 0. The alternative is that mu sub d is greater than 0. And keep in mind, whenever you have a one-tail test, the alternative has to be the claim. If it's a two-tail test, it could be either way. It could be the null hypothesis is the claim or the alternative, and you have to read the question. But when it's a one-tail test, we know that the claim is the alternative. So, is there sufficient evidence to support the claim? Well, we didn't reject the null hypothesis, so there is not sufficient evidence to support the claim that presidents tend to be taller than their opponents. So that's the end of the hypothesis test. But now we want to create a confidence interval. So in part B, it says to construct the confidence interval that could be used for the hypothesis test described in part A. What feature of the confidence interval leads to the same conclusion reached in part A? So, how are we going to find a confidence interval? Well, first of all, I'm going to look at the null hypothesis again. And remember that that's mu sub d is greater than 0. And our significance level, which is 0.05. So I'm going to mark that on our graph. So the area in here, that's alpha, is 0.05. And this is a one-tail test. But in order to find a confidence interval that will test this hypothesis, I'm going to make a matching tail on the opposite side. We happen to be in the right tail right now, so we're going to make a matching left-hand tail. So this area is also 0.05. And that means we have a total of 0.10 in the two tails. So the area in the middle, that's what I want to know about. That's going to be my confidence level. That is 0.90. So we have a 90% confidence level for this problem. So now I can go ahead and find my confidence interval by just doing t interval now. And we'll choose data. And our list is still L3, so it should be set on that already. And the frequency is 1. And then we give our confidence level, which is 90 or 0.90, either one works. And we get our confidence interval, which is going to be negative 7.4 centimeters is less than mu sub d, which is less than 10.8. So if we round that to one decimal place, that's what we get. So there's my confidence interval. And in the last step, we're going to interpret that confidence interval. Okay, so what feature of the confidence interval leads to the same conclusion reached in part A? Since the confidence interval contains 0, so the other options were only negative values or only positive values, but this confidence interval does contain the value 0, so that's why we would fail to reject the null hypothesis, just as we did in part A. And that's how you do that problem.